Radiography can be applied to most welded joints in the search for embedded flaws. It's important, therefore, that people involved in welding have some knowledge of the role of radiography as an inspection tool, be it X or Gamma Radiography. First and foremost, it is essential to understand that industrial radiography uses ionizing radiation, which is dangerous. During the radiographic exposure, where the source is uncontained, non-licensed personnel must stay outside the barriers posted by the radiographic team. X-rays are generated in an X-ray tube and projected in a conical beam toward the subject under examination. The production of X-rays is electrically driven and, therefore, no ionizing radiation is generated when the system is switched off. One advantage of this electrical production is that the wavelength of the X-rays can be changed and, because of this, so can the penetrating power. As can be seen, the equipment is bulky and the X-ray tube is delicate. It is best suited, therefore, for situations where the work can be brought to the equipment. Units are available in different sizes, generally up to 300 kilovolts. In contrast, gamma rays emanate from a radioactive source which constantly emits radiation 24/7. This radiation is of a fixed wavelength and it cannot be shut off like X-rays, only contained. Gamma radiation sources for radiography, usually cobalt-60 or iridium-192, are shielded in containers of dense material such as lead or tungsten to protect the operator from exposure. When the source is used, it must be remotely handled. A drive cable is connected to the source and projected through a hose called a nose tube. The nose tube is placed in a position from which the radiation passes through the object and thence onto a film. The drive cable is long enough to allow the technician to stay at a safe distance away from the source while it is wound or cranked out of its shielding through the nose tube to its position. During radiography, radiation will be directed toward the item under test, in this case a weld. A certain amount of radiation will be absorbed by the material and the remainder will pass through and impinge on the film that is placed in position behind the weld. When a weld has an internal flaw, more radiation will reach the film in these areas, causing a darkening of the film or a change in density in the film below the flaw. This difference in density is interpreted via its shape and its location to determine the type of flaw present in the weld. In this radiograph, the transverse crack running through the weld metal, heat affected zone and into the base metal is shown. A call can then be made to accept or reject the flaw depending upon the acceptance levels in the governing code or standard. Unlike ultrasonics, radiography cannot accurately size or locate defects as the film is not projected in 3 dimensions. The analysis of each defect depends to a great extent on the interpreter's knowledge of the welding procedure and their experience in this field. The addition of ultrasonics to the inspection process can assist in defining the location and the geometry.